All right, here we go with the first notes of semester 2, which talks about solving trigonometric equations. If you're following along with me, this is pages 2 and 3 in your Unit 4 notes packet. I want to start off with a little bit of review. Let's graph the trig function f of x equals cosine of x on the grid below from 0 to 2 pi. So we know that the cosine, its period is 0 to 2 pi, it's 2 pi, and it starts at a maximum of 1 and it ends at a maximum of 1. So at 0 and 2 pi, we have maxes of 1. Halfway through the first cycle, we reach our minimum, which is -1 at pi units. Halfway in between our start and our halfway point, or a quarter of the way through the first cycle, we hit our mid. So that's at our midline, and likewise 3/4 of the way through our first cycle. So we see the general shape of our function right here. And this is just the parent function, f of x equals a cosine of x. Now, don't forget to extend your lines past the endpoints here. I'm actually not going to draw in the arrowheads yet because I'm going to fill in the grid. Now I want to graph the function g of x equals -1/2. So use a different color for this. This is the function values that are -1/2. So this has the graph that looks like this here, like y equals -1/2. And I'm going to draw that as a dotted line. Now, I want to consider the equation cosine of x equals -1/2. In other words, we know that cosine in this case is f, and we know that -1/2, well, that's our g of x. So we're saying, where are these functions equal? Well, we know about systems, wherever two functions are equal are where they intersect. So we find the intersection point right here and right here from 0 to 2 pi. So looking at this graph above, how many solutions would there be from 0 to 2 pi? Well, it intersects twice here, so there are two solutions. Now, how many times would it intersect if we let the graph keep going? So I'm going to extend this graph and fill in the grid. So we've got a midpoint here, and it continues. And we have, this moves on and hits a minimum, and then we'll do the same thing on the negative side. It's a little tricky to draw that. There we go, nice round curves here. I'm going to sketch in that cosine curve. Nice round curves. All right. Now, how many solutions would there be if we let the graph keep going? Well, this has arrowheads. This is a periodic function. It oscillates up and down for all of infinity. It keeps on going over and over and over. So how many intersections would there be? There would be infinitely many. G of x also has a domain of all real numbers. Now let's graph f of x equals cosine of 2x. So the only thing we're changing here is how we are affecting the input of the function. This affects our period. If you're taking a look at this equation, you might remember from semester 1 that value in front of x is our b value. That helps us find our period. It is not our period, but it helps us find it. We can set up the equation. The period is equal to, in radians, 2 pi over b, which in this case, our b value is 2. So we can conclude that our period for this function is 2 pi over 2, or just pi. So we know the length of one cycle before it repeats is pi units. And then from there, it's just graphing cosine. So again, from 0 to pi, we start and end at a max. Halfway in between at pi halves, we hit a minimum. And at pi fourths and 3 pi fourths, we hit our midline. I'm just going to go ahead and fill in the grid here. So following this pattern, we go down and then up. We're going to go back down and back up and back down and so forth. Don't forget to fill in the grid on the negative side as well. And sketch your curve. Again, the sine and cosine waves are nice round curves here. No straight lines, no points at our maxes and mins. Nice round curves here. Also extend past your endpoints and draw in your arrowheads. Pull out your different color. Let's graph g of x equals negative 1/2 again. So if right here is -1, negative 1/2 is going to be right in the middle here. And I want to know how many solutions do we have to this equation, cosine of 2x equals negative 1/2. So again, this is where f of x, cosine of 2x, is equal to g of x, negative 1/2. So this is where the functions intersect. So from 0 to 2 pi, these functions intersect 1, 2, 3, 4 times from 0 to 2 pi. 1, 2, 3, 4. So we have 4 solutions between 0 and 2 pi. And again, how many solutions if we just kept going? Again, both of these functions have a domain of all real numbers. The cosine function is periodic, so it follows the same pattern for all x. So this has infinitely many solutions. Okay. Now, what if we continue to change the period? How many solutions would there be to the equation cosine of 1/2 x equals negative 1/2? Now, the change here from the parent function is this is a horizontal stretch by a factor of 2. So we're saying now that the period is 2 pi over b, or 2 pi over 1/2. The period is now 4 pi. So our b value tells us that our period is 4 pi. So then from 0 to 2 pi, we're only completing half of that first cycle. So instead of having 2 solutions in one full cycle, we're only doing half a cycle. So we're only going to have one solution. So for this first equation, we have one solution. For the next one, cosine of 4x, this is a horizontal compression by a factor of 4. So we're compressing the function. This b value, 4, tells us that we have a period of 2 pi over 4, or pi halves. So then, from 0 to 2 pi, we are completing 4 cycles. There are 4 intervals of pi halves width in 2 pi. Therefore, instead of 2 solutions, we have 4 times that, or 8 solutions. All right. Go ahead and flip the page. We'll get a little bit more practice. So now that we've seen what these solutions look like on the graph, let's see what these solutions look like on the unit circle. So for this page, I'm going to title it the unit circle approach. So let's find all of the angles in one rotation that satisfies this equation here. Cosine of x equals negative 1/2. Now, we already know this from the first page. But let's go ahead and find those exact values, okay? So we know that cosine corresponds with the x value. So cosine, what quadrants is x negative in? Well, x is negative in quadrants 2 and 3. So let's go ahead and draw in our terminal rays in quadrants 2 and 3. And these are just arbitrary. We're just sketching for now. Now, I also want to draw in my triangles. Now, notice I'm asking for the reference angle. If you remember back, the reference angle is the positive acute angle made from the terminal ray and the x-axis. So when we draw our triangles, always draw your triangles with the x-axis. So from these terminal rays, I'm going to define a point, and drop a perpendicular to the x-axis. All right, so we know that our cosine, or x value, is equal to negative 1/2. All right, cosine is equal to negative 1/2. Our x value is equal to negative 1/2. So on our triangle, we can label the horizontal, or that x value, as negative 1/2. Well, we know about special right triangles. We dropped a perpendicular. One side is negative 1/2. We know the hypotenuse is 1. This is the unit circle. So then what must be that vertical side length? Well, I see this and I'm thinking 30, 60, 90. So then that vertical side length must be my root 3 over 2. In quadrant 3, we've got negative root 3 over 2. Our vertical side length is negative in quadrant 3. So then what's my reference angle? We can determine our reference angle by determining the angle across from our vertical side length. So in our triangle, across from the vertical side length, well, what angle is always across from our root 3 over 2? That's our pi thirds, or our 60 degrees. So our reference angle, pi thirds, always across from root 3 over 2. So to use our reference angle to find the angle measures that give us our terminal rays, well, we know that the negative x-axis is pi radians. So then if our reference angle is pi thirds, pi minus pi thirds gives us 2 pi thirds. And to get to this terminal ray, we have to add pi thirds. So pi plus pi thirds gives us 4 pi thirds. So then the angle measure solutions are 2 pi thirds and 4 pi thirds. Now notice that's only in the first rotation. We could keep going around, right? We can find coterminal angles. So suppose that our domain was all real numbers, negative infinity to infinity. We could just keep going around and round, full revolution. So I can say that my solution, x equals, let's take that first one, 2 pi thirds. We can add a full revolution, right? 2 pi. We can add another and say 4 pi. Add another and say it's 6 pi, or plus 8 pi, and so on. The same is true for our other angle. We could say x equals 4 pi over 3 and add some number of rotations. Now, instead of writing out 2 pi, 4 pi, 6 pi, 8 pi, we're going to just call this 2 pi k, where k is an integer. Now, remember what an integer is. It's all of our whole numbers, counting numbers, both positive and negative. So it can be positive 1, so that's saying 1 rotation, positive 2, 3, 4, that's 2, 3, and 4 additional rotations. It can also be negative, so if we go around in the negative direction. If it's 0, then it's just that first rotation between 0 and 2 pi. So how would our solution change if our equation was cosine of 2x equals negative 1/2? Well, what's changed here? We've taken our x and we've changed it to 2x. So then instead of our solutions being x equals 2 pi thirds plus 2 pi k, we have 2x equals 2 pi thirds plus 2 pi k, and 2x equals 4 pi thirds plus 2 pi k. Now we want to solve for x, so dividing both sides by 2, we get the two solutions. X equals, instead of 2 pi thirds, we have pi thirds, and instead of 2 pi k, we just have pi k. For our other solution, we have 4 pi thirds becomes 2 pi thirds, and again, our 2 pi k becomes just pi k. And always include where k is an integer. So this is listing all solutions to this equation. Notice that k is an integer. We have infinitely many solutions here. Two forms, but infinitely many. All right, we got one more example. Here we have the equation 2 sine of 2x minus 1 equals 0, and I'm just going to go ahead and put parentheses around the argument of the sign. We want to solve the equation for sine of 2x. In other words, we want to get the trig function by itself. Get the trig function by itself. So solving this equation, 2 sine of 2x minus 1 equals 0. Well, first we have to add 1 to both sides. So we have 2 sine of 2x equals 1. And then we divide by 2, that coefficient out in front, and we get sine of 2x equals 1/2. Awesome, we got the trig function by itself. Sine of something equals 1/2. Well, we know, let's go ahead and use the unit circle approach. What quadrants are our triangles in? Well, we're looking at sine. Sine corresponds with our y values, and we notice that it's positive 1/2. So which quadrants is our y values positive? That's in quadrants 1 and 2. Go ahead and draw in your triangles. Again, down to the x-axis. Don't draw in those triangles to the y-axis. Always to the x-axis. By definition, that is our reference angle. It's that angle made with the x-axis. So quadrants 1 and 2. Reference angle. In order to find that, well, we know that our vertical side length, our y value, our sine, is 1/2 positive. So then our reference angle, that angle across from our vertical side length, well, what corresponds with 1/2? That's our 30 degrees or pi/6. So our reference angle is pi/6. And then to find these angle measures, well, we're at our x-axis is 0 radians and pi radians. So then this first angle would just be 0 plus pi/6 or pi/6. And then our second angle would be pi minus pi/6, which is 5 pi/6. So then our two solutions in the first rotation is pi/6 and 5 pi/6. So then we're going to list all of our solutions. Now notice that we found sine of 2x equals 1/2. So we're saying that the argument of the sine here must be equal to 5 pi/6 and pi/6 in the first rotation. So then we're saying that our solution is 2x, the argument of the sine, is equal to our pi/6 plus 2 pi k and 5 pi/6 plus 2 pi k. So we're saying in the first rotation of sine. But we need to find x by itself. So we're going to divide both sides by 2, and we get all of our solutions here. X equals, divide both terms. So pi/6 divided by 2 is pi/12 plus pi k. And then our other form is x equals 5 pi/6 divided by 2 is 5 pi/12. And again, plus pi k. Okay, where k is an integer. All right, so we're going to get a whole lot of practice on this. This was solving trig equations. We'll see you tomorrow in class. Bye-bye.